Hey, thanks everybody. Thanks for coming out early this morning. As was mentioned, my name is Bryan Williams. I'm based in Colorado in the United States, but you can probably tell that I'm actually originally from here. I grew up in a small town where they do a lot of car racing out in Bathurst in New South Wales, so a long history there. I've worked in lots of places all around the world. Been working closely with Ken, who you know a lot better. Over the last 15 years, I've been at Trimble and developing field technologies that can be applied to construction sites. So I'm going to talk today about some emerging technologies, but they're actually technology you have access to today. It's just the way that you can apply it, the way you can integrate it, and the way you can use it to improve things that you're doing. This clicker works. It does. So at Trimble, the buildings group is relatively new group, but it's actually been made up of lots of divisions that have been working together over a long period of time. So what we're really focused on is the whole life cycle of a building. So basically once the building starts to come out of the ground, we're really focused to provide technology. So whether it's a conceptual type of stuff, maybe using something like Sketchup to come up with a drawing and a concept of a design. And then once it starts to get detailed out, we have solutions like Tekla, which we focus on providing a constructible model to the end customer. That is something that you can use to build from. A concept model is just that. It's some architect's idea of what a building should look like. It doesn't really tell you how to actually put it together. So that's why we work on the constructible model, to make sure that you have something that you can use to build with. And right through the whole solution, at the end, we have a software called Manhattan within Trimble Buildings Group, which helps you manage the building. And obviously, the large cost of any big building is the cost of maintaining it over time and refurbishing it over time. So it's an important part to manage it well. So I want to start out with some of these statistics you probably know very well. And we're trying to focus on improving small parts of productivity. It's very difficult in the construction industry, because you can see from the chart on the right-hand side that productivity in construction has been going down over time, whereas other industries it's been going up. And that's just a matter of the way that we do things. You know, we know how to do it. We know how to do it a certain way. The job gets done, but that doesn't mean we do it in the most efficient manner. So we focus on trying to provide technologies that can improve that little by little, not only to improve productivity, but for people to actually gain and make extra percentage on the profit margin that they have on a project as well. And to also learn and apply what you've learned over time so that it's beneficial for the next project that you do. And that's a little bit about what the BIM process is all about. It's not just about managing one project, but what you can learn from that to manage the next project better as well. So one of the technologies I want to talk about is 3D scanning technologies. Have many people used 3D scanning technology? So there's a few people in the room. That's good to see. One of the benefits you can get out of 3D scanning technology is you get a high level, high fidelity detail of what's actually existing there. So you can really build accurate BIM models, because you have very high level of detail, and you can choose what detail that you model. It always documents the as-built condition very well, so either pre-construction, using it for pre-construction planning, especially if you're refurbishing an older facility. You can also use it, and a lot of people don't realize this, use it to track progression as you go along. So being able to determine things like, are things actually put into place? Is the floor level? And then doing checks against that progress, and then you can help that with determining things like scheduling the next contractor to come in and fulfill the next part of the process. And then at the end of it, you can actually produce deliverables out of it. And what people are starting to realize is the 3D point cloud can actually be your final as-built. And you don't need to necessarily model it. The information is all there. Later on, if you need to, you can use that data, bring it back up, and then model it. So you don't need to actually complete the model, because software today, which was very different to when I first got into 3D laser scanning, which was in 2001, when laser scanners were about this big. They scanned at 70 points per second. And today you have scanners that are this small and they're scanning at 2 million points per second. It's incredible advancement in technology, but what also held it back was the fact that none of the design softwares took point clouds. So you had to take the point cloud, model it, and then provide that as the end deliverable. Today you can take the point cloud directly into your design software and start to use that information to do your design or do a comparison against your actual design. So the construction verification, it's a great technology for using it on an everyday job site. So here's some examples. If you're doing to retrofit a mechanical room, for instance, and you want to know what's existing there so that you can take out what's there and then prefabricate and put into place the new piece. So this is an example of that. So here you can take from the 3D point cloud, you can take measurements, you can do some modeling from the point cloud, so that's the blue area you see there. And then you can bring it into your design software. So this is inside of, you can see it visualizing in Navisworks, but you can use inside of AutoCAD software like Cisco, where you have prefabricated parts and fit them into place within the point cloud to see if they fit. So here's the final fitment of the new design, and you can see that how that compares to the as-built, which is just the point cloud, and they're just modeling the new pieces. So there's no need to model, you just use the point cloud because it's accurate information. So another example is this was on actually a Google building in Colorado, and they're doing pre-tension cables and also placing lots of embeds in there as well. And so here's a scan of the area before the concrete pour. Then you have a scan after the concrete pour. And then what you can do is you have a record of what has been constructed before and after. So when you come across a problem, does this have a laser pointer? It does. You can see these penetrations here, which is just some pipes coming up through. And after they had checked it, they could see that it actually was misplaced. So the advantage now is, okay, we actually have to move these over to here. The problem is I need to know where these, the rebar is and the pre-tension cables are, so that if I drill through the concrete, I don't hit one of these. So what we can do is get accurate coordinates, mark those out, and actually drill through in the right location. So what you can do is also verification. So when you start to do things like construction of steel, you can do a scan of it, compare it against the design. And there's software that can automatically, in this case, you see the red parts here, the steel is actually in a different location to what it was designed. So you can make sure you can verify what's existing, what's maybe missing, hasn't been built yet, stuff that still needs to be constructed. But you can see the scan data here, and you do an automatic comparison, and you can determine the differences between what was designed and where it actually is. So you can see the point cloud here and the new piece is modeled. So you can see there's quite a difference here. That doesn't mean we actually need to take it down and reconstruct it. We can make a determination of, is it still going to be strong enough to hold up what we've actually designed. So as always in construction, nothing gets built perfectly all the time. So we have to make some assessments as we go along. Is it still going to be as intended in the final build? So in this case, maybe we can cover it up, but still but still the integrity of the building is still together. So here's an example of a point cloud in a mechanical room. And the great part about point clouds, it's very visually strong. You also can take images that colors the point cloud, so you can determine, one of the advantages of that with a color point cloud is you can determine things like, is that a water pipe, is that a gas line, is it cold water, hot water? So you can determine exactly what you're working with. You can see here, you can measure the diameter of the piping. You can take measurements from the point cloud very accurately, basically within millimeters. And in this case, we're going to take some measurements. Then we're going to cut out a portion of the point cloud. We're going to then take that into the design software and use that to do and fit the new portions of the actual design. So maybe we can fast forward a little bit here. so it doesn't take so long. So here's cutting out the portion that we're really interested in. We can visualize it from all sorts of angles. We focus on just one certain area. So you can see here that we can determine this section that we need to cut out and replace. Then we're going to export that into the design software, hopefully. Just click ahead here a bit. So now we're inside of Revit, and we're using the point cloud, just a section of it, not all of it. And now we're going to use the prefabricated pieces, fit them into place, and then we're going to see how that fits with the existing structure. So we're starting out with the portion of the point cloud. We pick the pieces that we want, and then we can start doing our design work without having to do any pre-modeling. We're just using the point cloud as the as-built. So it's easier for us to just select the elements that we need and start doing the whole design work. So I built it up quite quickly. And you got a pipe run here as well, and then you can also build the hangers based off the pipe run. So here's placing the hangers. And you can see how it fits well with the top here. And then you just then bring that back into the point cloud. You can see how that pipe run is going to fit through the whole facility. That's very good. So that's where we get into another technology, and that's mixed reality. So here I have a hard hat. It's industry certified hard hat with a HoloLens. So I'm going to explain a little bit about that technology and how you can use that in relation to construction. So one of the things that Trimble has been working on is developing field technologies over a long period of time, and sometimes the ideas take a long time to come into fruition just because technology doesn't catch up fast enough. So here's an example of that. Back in 1997, one of our groups based in Christchurch in New Zealand was developing some technology.
New Zealand's weird and wonderful inventions is being showcased at an international event in Christchurch. Science ministers from APEC countries are meeting for a conference this week, and they'll get to see the best of Kiwi science and technology talent.
Oakley might look a little out of place. That's because he's entering a whole new world.
Augmented reality is a technology that enhances the user's view on the real world. It's a system that can overlay computer graphics in real time into the user's surroundings.
It uses software that's been co-developed by companies HitLab and Trimble. This system's still in its development stages. They want to make it lighter, smaller, and cheaper. But to see more of this house, I need to put this on. It'll let me walk through the house, even look out the window at the real world.
You can see a house before it's built, so you can say, I'd like to add a new room. The prospective buyer can say, let's change the colour. The road engineers can problem solve in the field. We have a native tree. We need to move that around.
So you can see back in 1997, the idea was there. You can see it's not too far away from what it is today. It's connected on a hard hat. The big difference is I don't have to have a backpack, and I can also measure where I am by just mapping the environment automatically. So you can see the ideas were there, but it took till 2016 for the technology to catch up to be able to implement it. So you have to be patient when you're developing some technologies. So one of the things people always ask about, what's mixed reality, what's virtual reality, what's augmented reality? So we have some definitions around that. When you're in a virtual environment, you're basically replacing the normal world with a whole virtual world. So you basically cut off. So you can see those glasses that person has on, cuts off your vision of the world around you, and you're in a virtual world. And that's what a lot of gaming technology is around, creating a virtual world to be able to play games. And some people even use that to do design work as well. Augmented reality is where you have digital content that's you can place it into an environment. So you can walk around in your environment. You can see there's that's on like an iPad type of device where you can walk around and you can see some of the aspects of the real world and the design or the intent that you're looking at. With mixed reality, you actually can have the digital world placed in the actual real world, and they all line up together. So that's what mixed reality is about. That's what the HoloLens is about. When you put it on, you can see the environment around you, but you can also see the digital content overlaid and matching up with that environment. So what helps us on a construction site is you can walk around and you can see the design intent versus what is actually being built at the time. So when we first developed it, it was very good to use for design as the technology grew. We built an application that runs on the HoloLens called Sketchup View, and that allowed you to view the models and review it and mark it up. Then we wanted to bring something where we can actually take it out to the construction site. So we built a technology called Trimble Connect, which allows you to bring portions of different models in, walk around in the real world, mapping as you go along and seeing and matching what's actually being constructed. And then in the future, we want to bring that to where you can use it in an operation level on a building as well. So you can walk around, click on an object and get information about it. So that's where the power of BIM comes in. If you do that designing and you have all that information, you can recall that back up in the real world as you're operating the building. So some examples of that, in the design phase, it allows for, and I was listening to Liam was speaking yesterday on an infrastructure project. One of the big components about executing BIM well was collaboration. And that's what BIM helps execute on a project very well, especially on a large project like a roadway. But that also applies to a building. You have to have very good coordination to make sure that it gets built in a reasonable manner. Sometimes that's a little chaotic, maybe less organized than, say, an infrastructure project, which is quite large and has lots of planning. But from a design perspective, you can have people working together, either in an office environment, or you can actually be connected in remote locations together as well. So here we see people around a table. They've got their clients there. The client can see the conceptual design from a normal perspective and walk around it, and then they can immerse themselves within it as well. So you can actually walk around in what would be inside the building. So it allows the designer to share with who's going to be the customer the experience and get feedback from them directly to say, okay, do we need to make some changes? Is that the environment that you expected? When it comes to actually doing it on a site, we can help coordinate things. We can check against work. We can help identify things to save time in actually reworking. And it's getting too close to an accuracy where it's very acceptable to say, okay, this is in the wrong place. So in this case, you saw before when we scanned that mechanical room, this is back in that mechanical room now with the HoloLens, and we can place the model design now in the real world, and we can then compare that and take measurements against the real world versus the actual new design, and we can see if those pipe runs are going to have any clashes. So you can see there, the HoloLens, what it's doing, it has some sensors in there, structured light sensors, that is mapping the environment. So as you see that mesh, that's actually the HoloLens mapping the real world. And so what we can do is we can pick some locations on the wall just to define some planes so we can line up the design model with the real world. And so that's the process we're going through right now. And you can see here, in some slight adjustments, we can fit where the design should be against the real world, and then we can take some measurements and do some checking. So now it's lined up, and you can see that pipe run that we designed before is running through. We can see where the hangers go up and see if they're not impeded by something that's existing in that structure. So you can walk around in the environment, and as you walk around, you're seeing the design and you're seeing the real world at the same time. And that's one point from a safety perspective. With mixed reality, you can actually see your real world, so you're not tripping over something, you're not running into something at the same time. And one of the benefits of this helmet attachment is if there's an emergency, I can quickly detach the HoloLens and keep my hard hat on, and there's a tether that goes with it, so it just hangs around your neck. So if you have to climb down some stairs or down a ladder, you don't have the HoloLens being in the way. So that was one of the parts of this project, developing this, this helmet attachment with Microsoft. So you can see here it's taking measurements. You can measure the real world, you can measure the design versus the real world, or you can actually even measure model to model entities as well. So you can measure lots of different things. So if you need to make some adjustments, you can provide that feedback. So when it comes to operating mode, mixed reality then becomes applicable to making sure that things are going well. If we have to make some changes, we can actually get some information about what was actually constructed, because we're getting that information from the BIM model. So here's an example. You see one of the other things is today, that person is clicking on elements, but they're actually now, within the HoloLens, you can actually recognize QR codes. So you can walk around, it can scan that QR code, that information pops up automatically as well. So that makes it even more useful, because I can just walk around the environment, getting all that information as I walk around. So it's kind of like like in a fighter jet, you have a heads-up display, and you're getting all this information constantly in front of you. It's just a matter of managing how you manage it. So what other elements, what things are developing for the future? So some of those are actually coming to fruition now. So this one is called Sight Vision, where you can actually go, one of the restrictions to the HoloLens today is it's very sensitive to light. So this works very well inside, or if you're under a deck on a newly constructed building where there's not too much light coming in. But when you take it outside when there's lots of sunlight, you can't really see anything. And also the light sensors are obstructed as well. So that's something they're developing for the future to improve. So we're working on several different types of applications that can also run with other devices. So when we develop applications, we make them sort of platform neutral so that you can use it in different environments. So this is an example of that.
We've always gone out to a job site during the bidding process to look at the area, to identify what challenges there might be. But this is the first opportunity that we've had to use the Trimble Catalyst with the Google software, and what it enables us to do is to go out and look at the design to be constructed overlaid on the actual site conditions in real time. The ability to actually visualize what's going to be constructed before it happens is an enormous advantage.
So a lot of these technologies now are starting to be implemented. You see stuff on the HoloLens. Sight Vision is very close to being able to take that out into environment. You can see we have one of our very small GNSS receivers that you can attach to a device very simply and actually walk around in the real environment. So it's just different platforms for different applications at the moment until there's like one technology you can just wear around all the time. So other technologies that maybe have been around for a while but are becoming more applicable, especially to contractors on a job site. So one of those is layout technology, so with robotic total stations. So many years ago, my background is in construction surveying. You relied a lot on the surveyor to come out and tell you where to put things and lay things out, and then you pulled out your tape and your string. The problem with that, it's a little unproductive. You're waiting around for somebody else all the time. And we want to be able to provide that technology to everybody so that all of us can take advantage of that, the ability that technology gives you to make sure that as a contractor, you're not slowed down by somebody else, waiting around for somebody else to do things. And when I was working for a contractor, that was the most painful thing, if I had to wait around for somebody else to take the next step on the job. So we're applying that technology so you don't have to wait around for everybody else, but you have all the capability of somebody who has those skills. So this technology not only allows you to do accurate and productive layout, but it also provides you information in this BIM process where it helps with project management, scheduling, and future estimates. So we're collecting a lot of information as you're doing a simple task like laying out a point. So manual methods in the past took a lot of people. One of the downsides to me also was mistakes were made, but they're never actually recorded. And also there's no transparency on what has been done because nobody's actually writing it down and providing it to somebody. We're just marking it out, we're building something. If it was built in the wrong location, we discovered that later, not during the actual process. So you get examples like this one here where you have a penetration in the concrete for the piping to come up, and then they build the wall, and it's in the wrong location. So one of the problems here is now I have to move the wall. Well, what that does is reduces the square footage of that area, which means as an owner, I can't charge as much for that square footage area. This mistake was on an actual job. It cost $1 million for this mistake because it was put in the wrong spot. That's a lot of money. It also means the contractor didn't execute in the right location, so they're getting deducted as well. So it's important to have good, accurate technology. So you can apply it in many different ways. If you're working on a deck, you can even use GNSS technology up there on the left-hand side. You can check work that you've been done, which is this top middle one here, just checking. When you're erecting stuff or even building multi-family type homes, and even on large projects, you can see the technology can play it in a lot of different ways. A lot of different types of contractors using the same technology. So here's a mechanical contractor. He's out on a pan deck or a corrugated deck here, doing the mark out on top. That's not always possible, but in this case, they were able to do it. And that allows them then to have all the hangers punched through from the top. And so then when they go to place all the mechanical stuff, they can actually do prefabrication, and it's going to be accurate. So they know ahead of time that if I build these pieces off site and put them into place, they're going to fit. One of the biggest costs for any MEP contractor is if doing a lot of fit changes on a job site, that costs you time and money. So if you can prefabricate the parts and just put them together, it speeds up your process, and also you're taking less labor cost to get it actually fitted into place. So what we try to do is provide solutions that provide constant feedback of information. So it's not about just the layout tasks, but also we have in the field software we have is called Trimble FieldLink, but lots of other providers provide similar sort of things. But what it's doing in Trimble FieldLink is recording everything that you do. So it tells you if the point was placed in the exact location. If it's not, it tells you what that deviation is. If there's a major deviation, it will record that, and then when you bring the data back in to your design software, it will highlight where the mistakes are, because then you have to make a decision. Are we going to continue where we've created that location before we actually start constructing it, or are we going to move it and make some major redesign changes? So that information becomes pretty critical, because you're trying to do as best you possibly can to the design intent. And in the past, if you laid it out by string, nobody recorded it, it got built, and then we have to make some adjustment later. It's much more costly. So we try to integrate the workflows with different design softwares. You can see in AutoCAD and Revit environment, SketchUp environment, Tekla environment, where you're doing high detail models. And so when you take the data in the field, you have a digital representation of the model in the field. So you can see a full 3D model of the structure. You can turn the layers off and on and just show what you want. When you're doing layout, you can be in 3D. The advantage of that, instead of the old 2D way, is you can see, this is like an open deck, but you can see where the intended structure is going to be. So having that 3D model doesn't actually necessarily speed up your task, but it might be, oh, I see that if I laid that point out, it's going to be in the wrong location. What effect is that going to have? I can make a decision. Do I offset it for construction? So that then if they're going to build a wall there, the interior wall guys can say, okay, yeah, we can move it this way a little bit, and you can make a decision on the fly, or you can contact somebody straight away. You can take an image of it and provide that information to help somebody else make a decision. So before, if you did this string and tape, it would have been a lot of plans that you're managing around, whereas this digital method is you have it all in the power of a computer that you're carrying out in the field with you. And not only does it control the instrument, but it gives you a lot of extra information. If you click on one of the entities of the model, it will give you all the BIM information if you have an IFC model in the field with you. So here's an example of the information returning back to the office. These clouds here are highlighting the fact that the point from the design is actually in a different location. And that's generally when you're laying out, this error is made, but you're going to set some sort of standard of how big an error that you're going to allow. So this cloud is saying, well, that's outside that standard. What does that mean for us? Do we need to do a redesign of the pipe run, for instance? So that information is coming directly back into the field, back into the office in real time. You can connect as long as you have some sort of internet connection. You can send that information directly through. We have a cloud service called Trimble Connect. And basically you can manage all your models in the clouds. It's like a consolidated data engine, in fact. Or you can email it. You can put it on a stick and give it to somebody who's heading back to the office. There's many different ways you can share the information, but it's all digital. And when you pull it back into the model, it's going to do a quick comparison for you. So also, there's specific applications you can run with the layout technology as well. So in this case, we can do a quick scan of the floor with a total station, and it will compare against what the design level was supposed to be. So then it will highlight in the field on your tablet where the area is low, where the area is high, or if it's within the tolerance. So what does that mean is I can mark out these areas, low and high, and I can make a determination. Do we need to put some leveling concrete in there? Do we need to have somebody come down and shave it? So a good example is maybe like a hospital where they have a lot of high sensitive machines that they have to put in place, and they don't have much tolerance about how they can level it up. So having a level floor becomes highly critical. So to quickly measure that and mark that in the field saves time and energy than discovering it later on when you're trying to put that piece of equipment in there. So those infill applications become very powerful. And there's a lot of reporting mechanisms, as I mentioned before. So we have summaries that you can run at any time, provide that information back. That information then can be used and assessed to say, I send a crew out there to do the layout. One crew can do 400 points a day, another crew can do 800 points. So that way, when I know I do the next type of job, I know how much time to allocate for these guys to actually do the layout. And then I can schedule the next series of contractors that's come in around that as well. If we find an error, we can do a field report. We can use the camera inside the total station or inside the tablet, take a picture of it. You can see that it's offset. It's just a light pole. But sometimes that becomes critical because there's wires running under here. Maybe it's critical about the lighting area. A project like the Apple project in California, they mapped out the location of every tree they planted, and they had to be within 5 millimeters, every tree planted. It was quite insane, but they were very, very particular about everything they did on that job. So all this information can go back to an estimator, and he can use this information to see how well a crew performs. And I have an example of that from a customer about using this technology, how much that improved the fitment that they did, the percentage, but also the productivity gains they had as well. So as I mentioned before, that we can have with all this information that we've done by using these technologies, is that we can have better management of projects and also better estimations the next time we do a very similar project as well.
So what I love about our robotic total station, they're just so great because of the accuracy that we get on the deck and the speed on the deck. And for that, it's worth its weight in gold.
We're seeing an 80 to 90% success rate in our hangar installations. We actually purchased a second unit because we saw the value in the product. Our locations are utilized as the locations on site rather than all the other trades lines because we are using this digital solution. So our business goals are to build a culture of efficiency, growth, and satisfaction for the company as an entity and our partners and clients that we work with. We've gone from 2 people in the beginning to almost 200 now. We've worked on quite a numerous amount of projects within the city, residential, commercial, some institutional works.
We use Trimble field points and field links, so I would literally have the AutoCAD plugin, and I would just export it and import it right into the tablet within 1/8 of an inch accuracy. Before the Trimble, it was run up to the deck, pull my tape measure, mark it out, put all the locations of the cans.
One great success for us, specifically using the Trimble Total Station, was a large mechanical room at the University of British Columbia. Before anything was in the room, we went and laid down all the equipment and we built the room in a matter of weeks, where traditionally when you have the trade stacking, that project would have taken a matter of months. It's important for us to not just make it more efficient for us, but efficient for the people we work with.
It's a real selling point for us to the general contractors to say, yeah, we can meet your schedule because of this awesome system.
Trimble offers a wide range of products that help us build for the future rather than just meet our demands for today.
So you can see that, I mean, that customer is obviously based in North America because they use the term eighth of an inch. But the importance of showing you that is not to necessarily promote Trimble product, but the fact that they're using a technology. This is a trade using technology that was originally designed for surveyors to use, using that technology to control the way that they do things. And you heard some of the savings they get. 85 to 90% fitment is a big deal in placing that mechanical stuff, so they don't have to do refitting all the time. And they had productivity gains, and you saw one example there. They went from several months to do a project, like a mechanical room, to several weeks. That's a big saving. Not only that can they make the savings, it's a saving for the project, but also they can get those guys completed on that job and start working on the next job. So they're continually making money. They can schedule those guys. They know how much time they're going to spend on it. They know that they're going to do the job well, so they know then how to schedule the guys from one job to the next job. So that all becomes important, and that information can be used, as they mentioned, estimating the next job all the time. So it becomes very relevant. So technology continues to develop. We continue to evolve with that technology. Sometimes it's slower than we want. You saw in one case we developed an idea back in 1997 and it's only come to fruition over the last couple of years just because technology had to catch up to be able to implement that. But it's here now. Things like the HoloLens, for instance. You can come out to the booth there at the Building Point booth, and you can try it out and immerse yourself and get to understand it. There's layout technology out there. You can ask the guys about it. It seems scary to use some of the technology, but once you start using it, the important thing I've noticed about contractors is they know how to build. And if you give them the right technology and simplify it down enough, they can be very productive with it. And that helps not only just being productive on a job site, but it helps with the concept of the whole BIM workflow, because that's not easy to execute. It's not always ideal for every job, but you can take elements of it and apply it to different types of projects that you're doing. It doesn't have to be the whole workflow like a big infrastructure project or a 100-story building. It can be simple parts of it for even small jobs as well. So, and then I can take any questions that you might have.
Surely there's a few questions.
You would think, I think they maybe need some coffee. I don't know. Yeah.
In terms of battery life, is that technology?
This HoloLens? Yeah, it's about 2 hours.
Okay. Is there options to extend the battery life, like a bigger battery system?
No, not today. Not without some sort of fancy backpack, which would be sort of prohibitive to using it, but you can do that. Then they're working on the next generation, so maybe the battery life. One of the feedbacks, HoloLens is developed by Microsoft. We work very closely with them. So some of the feedback we gave them was like, for a job site, we need to have, a full day's battery life if possible, or at least half a day so that you could charge it up at lunchtime and stuff like that. So today, it's kind of power hungry because you have lots of graphics, so it sucks through it, and it's still quite small. So they'll improve that for the next generation, I'm sure. Yes?
How well incorporated is this technology into the mainstream building industry in Victoria?
Victoria, I probably would say people are using it for design work today. Layout technology is used a large amount. HoloLens type of technology is really more people using it for design at the moment. But people are starting to take advantage of and use it on job sites, but little by little at the moment. But layout technology is used extensively.
Is there a tipping point for the price at which this sort of layout technology becomes viable?
Yeah, so we keep developing solutions from, like, I would say, low-end to high-end capability. So you have a range. So you can start out at a lower end and build up to having more capability. And we built the software in a way that you can add to the software your capability to take advantage of additional technologies. So, you know, if you develop over into 3D scanning, for instance, you're using the same interface essentially. So you can apply different technologies, but still be familiar.